the reality that seems to be the case with our species is that we are constantly migrating and mixing with each other, and that there's no such thing as groups that have been somehow pure in the same place for a long period of time. We are all mixed.
But while we were looking at what it means to hand over bioinformatic intelligence, which is what David feels that we are bioinformatic beings, we want to look at another dimension of being human, and that is through a time travel machine that takes us back thousands of years to look at the power of nature, evolution, natural selection that has gone into creating human beings as we understand of ourselves now. If you look at the sort of age of the planet, it would be 1 year. In that, human beings have been there only for 10 minutes, and we, as we recognize ourselves today, is only 2 seconds. So really, kahani baki hai abhi in terms of what we can evolve into. But to understand what we can evolve into, whether these are tall claims, whether they are real, it's important to understand how we got here and who we are. And to examine that through ancient DNA, we have one of the foremost paleogeneticists in the world, who's David Reich from Harvard University, who has done definitive work that has changed the narratives and understanding of ourselves, our evolution, and how we got here as species and inhabited the planet. Ladies and gentlemen, please welcome David Reich. David, before we dive into the many complex things that you have been up to, I just wanted to share a couple of quick facts with the audience. It came as a shock to me to know that we're, only 0.1% still separates us from chimps. Otherwise, 99.9% we are still chimps. It's only 0.1% that has created this whole huge exponential intelligence burst, which is modern humans. David and others' work, Swante Pabo's work, takes us back 70,000 years and more to look at how Neanderthal genes, they've kind of mapped the genome of Neanderthals from a shard of bone, Denisovans. These are prehistoric, other forms of Homo genus, and how their traces still continue in modern humans. So as I said, it's a kind of humbling perspective on what has gone into making us before we handle that baton and mantle on to other species. So David, as I said, you've done this absolutely amazing work, which shows that Neanderthal genes, Denisovan genes continue to play a role in the creation and who we are as modern humans. So do start with that story. One, that we've managed to do this genome mapping of such ancient species of humans, and what is that persistence of their genes in us? How is it shaping us as modern humans? What impact does it have?
Sure. So maybe 70,000 years ago, there were really at least 5 groups of humans, much more different from each other than anybody living today. Today, we're all much more closely related. We're all alone in the world. But only 70,000 years ago, there were many, many different groups of humans who were living together. And one of these groups was distributed in Western Eurasia. Was the Neanderthals that had been studied for more than 150 years. And it was big-brained, made very complex tools like the ancestors of anatomically modern humans, which we are. And the question was, how these anatomically modern humans, which arose first in Africa 300 or 400 or 200,000 years ago, and Neanderthals, who had been studied for 150 years ago and made tools as complex as modern humans and had brains as big as modern humans, how do they interact when modern humans expanded out of Africa and the Near East into the range where Neanderthals had inhabited it? And so when it became possible to get DNA out of ancient bones, the first DNA sequences were only published in 2010, so recent. The question we all were very interested in was, how did Neanderthals relate to people today? And so the results were very, very surprising. I think that when we got Neanderthal sequences led in Svante Pääbo's laboratory, and I got to be involved in analyzing these data and thinking how they related to modern humans, we came to it with a very strong impression from analyzing the DNA of people today that the ancestry variation in all people outside of Africa today, people in the Americas, Native Americans, people in South Asia, people in Europe, people in East Asia, people in New Guinea and Australia, were all a small subset of the variation seen in Africans today. And there wasn't any evidence, it seemed to us, and it seemed to many of the people working in our field, and certainly in my own academic lineage, that there was any DNA from these archaic humans that we must have met. And then when we got the DNA, there were just very clear evidence that there was interbreeding, that non-Africans, not specifically Europeans, which is the main place Neanderthals lived, but even more maybe East Asians, or even more maybe New Guineans and Australians, or even more maybe South Asians and Native Americans had more Neanderthal DNA than did Africans, who maybe have none. And so this is very surprising.
So, David, as you said, that it's surprising, and it shows that there was a lot of interbreeding between the modern humans and Neanderthals and Denisovans, and that this still, so one is the admixture, that we think of ourselves as pure races, but your work showed that there were multiple races, multiple human species across the planet. They were interbreeding. They were going into Africa, back out, so there were waves of migration happening. But as I asked you that, one is to be shocked to realize that we have Neanderthal genes in us. Even Indians do. We have Denisovan genes, and it goes across down to even the Australian populations. But what I found surprising and shocking was that it impacts human health even today. So can you give a little insight into that? What aspects of human health is defined by that little trace of Neanderthal genes?
Sure. So, of course, about 2% of the DNA of non-Africans today, including South Asians and Europeans and East Asians, is from Neanderthals. And there's also another archaic species or group that we discovered just from the DNA, the Denisovans. And the DNA lives on in us. And there's so many traits that are encoded for by the DNA that if you take 2% of them randomly and distribute it in the genome, some of them will have impact on health. So examples are ones that help people in Tibet adapt to high altitudes. Those come from these archaic Denisovans through interbreeding. Another example is the very high susceptibility of some people to COVID-19. There was a discovery by Svante Pääbo and Hugo Seeberg a few years ago that the strongest risk factor is this factor that comes from Neanderthals and is highest frequency here in South Asia and makes people tend to have a more severe form of the disease than people outside, although not everybody or even a small fraction of people carry this risk variant.
So, and just to add to that, even bleeding in pregnancies, and you've already mentioned high altitude breath, immune systems, all of that is still impacted by, like you said, this tiny trace of Neanderthal genes still in us. So that's just amazing. Before moving to some of the other really pivotal findings that you've had, David, I just wanted you to share again with the audience, maybe pick two surprising, which shifts our thinking when you talk about admixture and about migration, and migration is such a modern topic, and it's such a sort of explosive topic, that it's fascinating to know that 70,000 years ago, 40,000 years ago, 2 million years ago, there were just migrations happening across, across the planet. But give us two surprising, say for instance, European self-conception, or the British self-conception that, they think they're a pure race. Give us an example of who the British really are.
Sure. So, oh, wow. So, is this too loud?
Yeah, it is. You know, there's a lot of blowback on stage,
Yeah.
so I'm finding it hard to hear. Yeah.
So the dogma, the orthodoxy prior to the advent of ancient DNA was that the spread of humans around the world after the migration out of Africa, or out of Africa and the Middle East, which happened maybe 60 or 70,000 years ago and encountered Neanderthals, that people spread to different places, and the ancestors of people who live in each of those places now were the ones who first arrived there. And we really couldn't test that. But with ancient DNA, it's a time machine. It takes you back in time to the people whose bones you're discovering from cultures that you have been studied archaeologically, and we can ask how they relate to each other and people today. So as an example of the kind of surprises that have emerged from this work that were extremely surprising to many people, including to me, were the huge population transformations that occurred in various places such as Europe. So Europe, we know from archaeology, was massively transformed economically about 8,000 years ago beginning by the arrival of agriculture from the Middle East, which is the first place in the world that agriculture arises 11 to 12,000 years ago. And it was thought by most archaeologists that after this point, there couldn't have been a substantial impact of people from outside on this densely settled place, which was growing all sorts of crops efficiently. However, what happened is after 5,000 years ago, there was a large-scale movement of people from the steppes north of the Black and Caspian Seas, people who herded sheep and goats mostly, and were some of the first people who used wheels and carts. And these people expanded explosively from their homeland north of the Black and Caspian Seas all the way to Hungary in the west and to eastern China in the east. And their descendants rolled into Europe and displaced maybe 75% of the ancestry of the DNA of people who lived in Germany. And when it got to Britain, it got there about 4,500 years ago. The last big stones at the monument of Stonehenge had just been built. And then there was a minimum of 90% population replacements almost within 100 years. Very radically transformation, turnover of the ancestry of the people of the island. And so the people who live in Great Britain today are hardly descended at all from the people who built Stonehenge. And this actually is true almost for every population in the world. Almost every group in the world today is not descended fully or often very much at all from the people who lived in the same place 3,000, 5,000, 10,000, 20,000, 50,000 years ago. The reality that seems to be the case with our species is that we are constantly migrating and mixing with each other, and that there's no such thing as groups that have been somehow pure in the same place for a long period of time. We are all mixed.
David, it's fascinating you say that. And just to bring home the kind of marvel of the work that David and people like Swante Pabhu have done, there was a wonderful metaphor that someone used. The fact that they've been able to find this level of precision science is like shredding a Manhattan phone book, putting it into yesterday's dustbin, that going into a landfill, and being melded with the entire landfill and then piecing it back together from that. That is the level of precision science that they've been doing. So, David, you brought up this thing about our self-conception, that we are pure and that different races are pure. But, you've proved without doubt that there has been massive admixture across time. But there are 2 or 3 thorny things that your studies have revealed. One is about the identity of Indians, and I'm going to come to that. But before that, let's set up the framework of human difference in the first place. You've made this case that all Homo sapiens today are an admixture of those who came out of Africa, the Yamnaya, the steppe pastoralists, the Iranian farmers, the indigenous populations, maybe some bits of hobbit, Homo genus, all of that. And yet, there is racial difference between, human beings. And somebody like James Watson, who literally discovered the structure of the DNA, came up with this very terrifying idea that there's a cognitive difference between races. So help us understand what you think about this, how should one frame it, and if there's only 0.1% difference between us and chimpanzees, do these racial differences really count? What's your framework to understand this?
Sure. So It's very hard to think about the nature of human variation. We see around us differences amongst all these different people. They look different from each other, from different countries, and within any country, so different from each other. And I think that scientists like myself who get involved in understanding history have some kind of obligation to talk about this and to engage in the public discussion on the topic of how people are similar and different to each other, because if we don't do that, then that vacuum will get filled with pseudoscience and people saying what they think from their prejudice is the case. And it's almost always the case, just as in my own background in science, that one's guesses beforehand, one's prejudices, are actually not really accurate descriptions of the reality. In this case, I think they have almost no correlation to what's likely to be the reality. So the nature of human variation is such that we've known this for more than 50 years as a community, that the average amount of difference between two people in any one community, from the same community, is about 6 times larger than the average level of difference between a person from an average one community and another continent. So for example, if you look in a classroom, your grade school classroom at 20 kids, they're so different from each other. And the level of difference between 2 kids in that grade school classroom is about 6 times larger than the difference between, say, a European person and a Native American person on average, right? So it's small relative to the inter-individual difference, but the inter-individual differences are large, and so it's appreciable. So there are differences likely to be genetically amongst people on different continents. We have no idea what they are. We haven't yet been able to measure them in a clear way. The cultural differences amongst groups around the world are so profoundly huge that it's hard to disentangle them from the smaller relative differences in genetics. It should be possible to do it at some point, and then we're going to have an intelligent conversation about what those differences mean. But one's guesses beforehand about, for example, the athletic ability differences or the cognitive propensity differences between one group or another are, for example, the latter case, are almost certainly likely to be heavily influenced by one's cultural understandings of these groups. And discerning the genetic component from the very overwhelming cultural component is going to be hard. And so I honestly have no guess even about what the direction of the nature of these differences will be.
Right. David, I wanted to just share something else which we were chatting about earlier, to add to the framework that David already mentioned, and especially again now in a political environment where our differences are so accentuated as between races and nations, that, this one that only 0.1% separates us from chimpanzees, that within that there's a more 85% differences between 2 people or within a community, and there's only 15% differences between other races and nations, and that could be in height, it could be in susceptibility to disease, it could be in athletic prowess, and I don't know if there's any intelligence difference and if that's a difficult or unreal conversation that people have put forward into society. Do you think that that's at all a tenable argument? Or is that more because of the environment or social cultural constructs that would have been placed upon it? And the reason I'm asking that, David, is exactly what you said, that if people like you with your scholarship don't engage and put your perspective on it, then there'll be a runaway narrative by, say, some ultra-right group on, the varying intelligences of different national groupings. So what's your take on that particular parameter?
Sure. So I think that there is, it's interesting. I think that anthropologists and geneticists have been transmitting to the world, or many have, a kind of public message that there are no meaningful differences amongst groups of people for the last 50 years with regard to traits that people care about. And that's actually a deceptive way to communicate about it. And people acknowledge that there's differences genetically and biologically amongst individuals. For example, in a grade school classroom, people understand that some kids are more interested in one thing and some kids like to do other things or are able to do other things differently or better or worse or so on. People understand that, and we've built a whole political society and political philosophy around accommodating that variation and trying to give everybody the chance to succeed in that. People in general agree that people with 2 X chromosomes and people with an X and a Y chromosome are biologically different. Some people deny that, but most people think that's the case. And we're dealing with how to deal with that as a society, that difference that is amongst us. But a lot of people at the same time say that there's no possibility for a meaningful difference on average between people from two different continents. And that's a little bit funny because the differences there are much smaller than the differences between two X chromosomes and an X and Y chromosome, or two people in a grade school classroom. So we should build up a political discourse that's sophisticated enough to be able to deal with a small but real difference on average between groups, one that we currently don't know what it is, just a little bit like AI, which is the subject of the topic. We currently don't know how it will manifest itself, but we need to build up a way of talking about it that will be robust once we begin to discover that, I don't know, for this trait there's a small half standard deviation difference one way or the other. We need to be able to deal with that and not assume that it just doesn't exist.
So, David, I just wanted to come to the whole discovery and the sort of scholarship you've done on India and the nature of people in India. It set off a huge controversy because your scholarship found that there had been a migration of the steppe pastoralists. We've stopped calling them Aryans because there's so much of political, sort of electricity around the word Aryans. But you say that India is an admixture of three kinds of basic groupings, and that the Aryans came in and definitely mingled with the Indian populations. Tell us a little about it and also why it triggered such a controversy and your take on that controversy.
I think maybe it's...
And you're completely safe here on this stage, David.
I think it's maybe the biggest theme of my work and privilege to have written a whole series of papers on Indian population history. Of course, I'm not from South Asia at all, so in some sense I don't have a right to do this, but it's really been a privilege to be involved in this work. And what's very clear is that the history of South Asia is one like that of other places in the world, of it, layers and layers of profound population mixture. And so, beginning with our work in 2019 with K. Thangaraj, who's in Hyderabad, it was very clear that people in India today are mixed between two groups that are highly different from each other, as different from Europeans and East Asians. We call them the ancestral North Indians and the ancestral South Indians, and that everybody in India, without exception, is mixed. Nobody is in any sense pure, for example. And in later work, we found that these two mixed populations, the ancestral North Indians and the ancestral South Indians, came together between 2,000 to 4,000 years ago and mixed in different proportions to form a gradient of ancestry with people at different places on that gradient in terms of relatively more ancestral North Indian and relatively more ancestral South Indian ancestry. And in this later work, we also found that these two groups are themselves mixed of three deeper groups. The Iranian-related, but not necessarily Iranian group, a ancient Southeast Indian or Asian group, and a group that is descended from people of the steppe. And in the Harappan Indus-Civilization Valley period, where we have DNA, both from people in India and from migrants to the eastern Iran and to the Bactria-Margiana archaeological complex in Turkmenistan and Uzbekistan, we see that there are people who are migrants from South Asia who are from a different gradient. They don't yet have the ancestry descended from steppe pastoralists, the same ones who impacted Europe. So that's before 4,000 years ago. And then between 4,000 and 3,500 years ago, there is ancestry descended from these same steppe pastoralists who affected Europe that gets squeezed into South Asia. It's not much. It's at most 20%. In some people, it's close to 0%. But it's a substantial proportion of ancestry, and that squeezing creates the ancestral North Indians, who then mix in different proportions with the ancestral South Indians to form the gradient you see today.
So, David, just to share with the audience, this finding that David published, did set off a big controversy because there are also people in India who feel that, the Indus Valley people and others, indigenous Indians and the Aryans actually came out of the Harappan Indus Valley and moved out into the world. So there's this big controversy that you feel that the Yamanaya came into India, whereas there's a belief that it moved out from India into elsewhere. But another contentious thing in that, David, was the origins of, say, the Sanskrit language, and what you call Indo-European languages as well. So I wanted to understand, how did you come to the conclusion? Yes, through genetics, you can see that there's an admixture of people. And again, David found that the mitochondrial DNA, which is the female DNA, is unmixed in the Indian population, and it's only the male DNA which has come from the Yamanaya, so it shows that somebody came into India. But how do you come to a conclusion about the language, David? Because I think that's what kind of triggered people even more when you say that even the formation of the language was by people who were migrating in from other geographies rather than that it emanating from India itself. And one question there also is that the Harappan civilization was already very evolved, so there may have been a very mature language already in India. So how did you come to that understanding that maybe even Sanskrit evolved out of this encounter with the steppe pastoralists?
So many of you already know that there is a group of languages called the Indo-European languages. They're all related within about 6,000 or 7,000 years to each other, as reconstructed by studies of the rates at which language change. And this was identified actually in India more than 200 years ago, that languages like Greek, Latin, and Sanskrit were closely related to each other. And since that time, many additional languages were pulled into that family. So a question was always, if these languages are so related to each other, how did they spread to the various places they spread? Where is their first place these languages were spoken before they fractured into the different descendant lineages that gave rise to the languages spoken in different parts of the world today? Almost every European language is a Indo-European language, with a few exceptions. Armenian is an Indo-European language. Ancient Hittite, spoken in Turkey, is an Indo-European language. Tocharian, spoken in the deserts of eastern China, is an Indo-European language before it's no longer spoken. And Iranian and North Indian languages are also Indo-European languages. So genetics, of course, can't determine what languages people speak. We're speaking English on this stage. It doesn't have to be people who are of English descent. I'm not of English descent. But genetics is important because it can document movements of people that we may not have known existed, or that we were denying existed, or that we hypothesized might have existed, that occurred in large enough numbers that it could have plausibly conveyed language spreads. And what we and others have done, beginning in 2015, is we identified that a group that lived north of the Black and Caspian Seas, the Yamnaya steppe pastoralists, expanded explosively in all directions. They expanded into Europe after 5,000 years ago, and they mixed with European farmers. About a quarter of the ancestry of the resultant corded ware group became European farmer. The corded ware group in turn expanded explosively both westward into Europe and then retrograde across Eastern Europe into Siberia and also southward through a series of known archaeological cultures, and spread eventually into the boundaries of South Asia. The breakups and the branchings of the genetic spreads correspond quite precisely to the reconstructed splittings of the language. It's almost impossible to get around the idea that the actual movements of people traced by the DNA are the paths by which the languages spread. And in particular, Sanskrit and North Indian languages are related to Iranian languages, and are next most closely related to Baltic and Slavic languages, and we have exactly a movement of people that we have documented with the DNA that corresponds to the archaeological process that allows us to trace that.
So David, I'm sorry I'm cutting you, because there are all these, literally like thousands of centuries of knowledge that one is trying to put into half an hour, so sorry to butt in. I just want to, we'll have to close this. I just wanted to share with the audience that one other thing that David found was that this huge admixture of people that, he's been speaking of and his scholarship found happening across thousands, 70,000, 80,000, 2 million years, suddenly came to a standstill in India with the caste system, when suddenly all the genetic intermingling got frozen, which was another controversial finding that you had, David, but people can approach you and speak to you about that over lunch maybe. What I do want to ask you is, like we said, each speaker is bringing a different dimension to understanding what it means to be human. What do you think it means to be human, David? Given all the studies that you've done, who are we?
I think the answer that I've been giving to that question to myself for a while now has been, I have not been able to make significant progress into understanding who we are genetically in terms of biological coding, But the progress I've made, at least for myself, is to try to understand who we are with respect to who our ancestors are and how our ancestors come together to form us. And the pattern is quite different from the one I expected just 15 or 16 or 17 years ago. The pattern is one of a trellis of constantly mixing populations of groups that were extremely different from each other and mixed with each other on a scale of thousands of years or hundreds of years or tens of thousands of years, almost whenever they get the chance. And that this history of constant churning and movement and mixture and migration is really essential to who we are. The originators of these Indo-European languages, just as an example, are themselves hugely mixed of Siberians and Caucasus people and Eastern Europeans. The ancestors of South Asians are themselves hugely mixed of different groups, at least 3, maybe more. The ancestors of Europeans are hugely mixed of different groups, at least 3 or 4. It's not a rare thing, it's the common thing, it's our shared heritage. Mixture between 2 people, your mother and your father, is the very nature of who we are. We are mixed people from our immediate ancestors, and we're also mixed from this perspective of populations.
Thank you very, very much, David. I think it's humbling also to remember that our common ancestor is the chimpanzee. And somebody writing of David's work said that, while we're talking about an AI intelligence explosion, for the longest time, we thought Homo sapiens came into being as a kind of intelligence explosion, but we're not. Someone irreverently said of David's work that it's humbling and liberating to discover that we are all a product of some ancient ancestors having a bit of a sex encounter in the bush, and that's between Neanderthals, Denisovans, us, and we are the descendants of chimpanzees by 0.1% variation and deviation. That's quite humbling, David. Thank you so very much for joining us today. Thank you.